Hello, welcome again. This is Jim Corkins, and we are about halfway through the content in forces, and we are now doing 4.3 2D force diagrams, or 2D free body diagrams. Now, if you haven't done the reading, please start the reading. It will help you. Okay. Again, we've listed out all the contact forces in our course. And those contact forces are a force of a push or pull, which you would just subscript it with whatever's causing it. A rope force would be T, and ropes always pull. A spring force, which is the spring constant K times how far it's been compressed or stretched away from the equilibrium system, that is X. Compressed springs will push back against you, trying to snap back to the equilibrium position. A stretched spring will pull, trying to snap back to the equilibrium position. So this is often referred to as the restoring force. Now, a surface force provides two different types of forces. The normal force, which holds the object up, and then you have the friction force, which is parallel to the surface. And that one is that force is two different types of forces. A kinetic friction means it is moving, so the kinetic friction force is always opposite the velocity vector. The static friction force, which the object is not moving relative to the surface, but the object itself could still be moving. I know it sounds kind of weird. And that tends to be in the direction of the acceleration vector. Now, the other type of force, which is the non-contact force, this is mg. This is the weight of whatever you're doing the force diagram on. So this is the non-contact force. And we start our force diagrams off with this. And hopefully you're getting pretty good with force diagrams since doing 4.1 and 4.2. But we're going to continue on with it, but now we're going to have diagonal forces. So just like that trig review where we had diagonal forces, where we had to break them into up and down and left and right using sine and cosine, we're going to have to do that here. Okay? So let's start off with tutorials. Now these tutorials are, we're going to do 3 types of tutorials. And then you are going to do the other tutorials which have more information, okay? And these are designed to help you get really strong at force diagrams, okay? So let's go ahead and start. So here we have a force diagram, and it's kind of weird because we have a normal force pointing up and to the right. So that means there has to be a surface of some type here. And we have another normal force pointing straight down. So my only thinking is that we're in kind of a, well, so that means maybe something like this. Like we've thrown a ball up against the ceiling and there's something where it's hit right there. And it's sliding to the right. It kind of looks like that a little bit. So we've thrown a ball and it's in the corner of a kind of skewed wall. Anyways, that's what I'm thinking. But this is more about working with the numbers. Okay. Now, what we're supposed to do is we are supposed to create x direction and y direction equations and calculate the acceleration in the x and y directions. So that's the first part. And we are supposed to figure out the directions of the velocity vector in the x direction as plus, minus, or 0. And we are supposed to indicate whether the object is speeding up, slowing down, or constant velocity. So let's go ahead and try working this one out. Okay? Now, when you're doing these, it does help to lay down a coordinate system, because sometimes you're not given a coordinate system. You have to put that one up. So whenever I know I'm going to have to work with force diagrams, I try to lay down a coordinate system and label it. This little bit of extra work has always helped me out. And then we have this. And positive x is to the right, negative x is to the left. So what I'm going to do is I'm going to start marking these as positive or negative. So the weight of the object is 2 newtons. And while I'm here, if negative mg is going to be equal to negative 2 newtons, then that means the mass, and let's just call gravity 10, is going to be 0.2 kilograms. Okay, so now we know from the weight force, and I always start with that. And it looks like we have some other random force. Use purple here, which is right here. Now, I know this normal force is related to this friction force because they are perpendicular to each other. That friction force is always parallel to the surface, and the normal force is always perpendicular to the friction force. Let me think about that. That may not be right, what I just said. But anyways, we're just moving along. Now we have another weird force, and I'm going to use blue for this guy. And this other force, which is just, I don't care if it's a normal force, let's just call it a 12 Newton force. That force is to the right, and since that is a hypotenuse, it's going to be up and to the right. So I drew my little triangle around it. That vector is pointing up and to the right, so that means the horizontal has to be pointed to the right, and this vertical has to be pointed up. And now we're going to be doing that just like that tutorial from the trig review. It's going to be hypotenuse sine of theta and hypotenuse cosine of theta. So the 30 degrees is touching this side, so that is going to be the cosine side. So this is going to be pointed to the right, and it's going to be 12 cosine of 30 degrees. And this upward one right here has to be the sine of 30 degrees. Okay. Well, let's translate all of this stuff over to here. Okay. And you could just use the numbers, which is what I'm going to do. Or you could put in the symbols and everything too. But let's just use the numbers. Let's start with the x direction first. So we have a friction force to the left. And we don't even know if it's moving, so my guess is whenever they refer to friction, just like in my tutorials, that's always mu sub k, unless told otherwise. And then we have a 12 cosine of 30 degrees to the right. The cosine of 30 degrees is 0.866, by the way. All right. Now, we've accounted for our two forces in the x direction, so we're going to set this equal to the mass, which is 0.2 kilograms, times the acceleration in the x direction. And we could go ahead and solve for this right now. I want to wait, but we can solve for the acceleration in the x direction right now. In the y direction, we have two forces down and one force up. So I'm going to start with that upward force. That's going to be positive 12 newtons. I should have put newtons here. It's a little newton there. Actually, that's going to be confusing. 12 newtons, and that'll be sine of 30 degrees, and the sine of 30 degrees is a half. And then we have the weight of the object, which is negative 2 newtons. And then we have that other weird normal force, which is negative 4 newtons. So I'm convinced that that friction force and that normal force go together. And that's going to be equal to 0.2 kilograms times the acceleration in the y direction. Okay, so let's see what's going on here. Okay, so it looks like we have this, which is going to be 12. Let's do this top part. So this is going to be -3 newtons, and that's going to be plus 0.866 times 12, 10.392. newtons, and that is going to be equal to 0.2 kilograms times the acceleration in the x direction. All right, let's go ahead and try to figure this out. So that is going to be 7.392. So let's solve for the acceleration in the x direction. So the acceleration in the x direction is going to be -3 newtons plus 10.392 newtons divided by 0.2 kilograms times the acceleration in the x direction. Okay, so what is that? That is going to be 7.392 divided by 0.2. (36.96). So this acceleration is going to be a positive 36.96. All right. So what does that mean? Well, that means this is going to be a positive 36.96 meters per second squared. Let's find the other acceleration in the y direction. So this, when we put that all together, this is 6, 12 times 0.5, 6, minus 6, so that's -2 plus, so that's just 0. So 0 divided by 0. So that's 0 newtons divided by 0.2 kilograms acceleration in the y direction. So divide 0 by 0.2 kilograms and you get 0 meters per second squared. So this is 0. So that means we know this is 0. This is positive 36.96. All right. We have to figure out the direction of the velocity vector and whether it's speeding up, slowing down, or constant velocity. So the friction vector is going to tell us the direction it's moving. And so the friction vector is in the x direction. That is a negative number. So that is a negative number. So that means it's got to be moving to the right because the friction vector is always opposite the velocity vector. So that is moving to the right. Since the velocity is positive and the acceleration is positive, that is going to be speeding up. All right, that looks good. All right, well, now that we did a problem that way, that earlier way, now what we're going to do is another problem just like I taught you, similar to what we just did in 4.2, but now it's going to be a little bit, it looks like it might be a little bit more intensive. I'm not sure. We'll find out. But again, we are going to be doing inductive reasoning. And this is going to make our overall problem solving ability in physics a lot better. So here we go. It looks like we're given this as our x direction equation, and we have this as our y direction equation. And what I want to do right now is I want to simplify this a little bit. 77 newtons cosine of 30. I'm going to go ahead and turn that into a number. 0.866 is cosine of 30 times 77, 66.68. So I know this is 66.68 newtons. And I know this right here is 77 divided by 2, which is 38.5. So we know this is 38.5 newtons. So I'm going to put that into my force diagram, okay? And well, this is going to help me with my calculation, but let's construct our force diagram first, okay? Starting with the x direction. Actually, let's start with the weight of the object. Since the object is 29.65 kilograms, my guess is this is the weight of the object. So this is going to be mg. It has to be. So negative mg, that's going to be equal to negative 2296.5 newtons. Okay, so now let's switch to the x direction. Okay, we probably should just stuck with the x direction, then done the y direction, but let's do the x direction first. It looks like we have a friction force, which is probably kinetic friction. It's going to be pointed to the left, so I'm going to designate that purple, which is negative 0.2 times the normal force. Okay, and it looks like we have this other force, which we don't know what that is. That's going to be pointed to the right, and I'm going to just go ahead and write the sine and cosine here. Cosine of 30 degrees, because that's going to tell me where the 30 degrees is. But I'm also going to write positive 66.68 newtons. Maybe I should write it underneath it, which is, and this is positive, so this is going to be positive 0.68 newtons. So we know that force pointed to the right. Now we know the mass is 29.65. I'm going to write that in here. Kilograms. All right. Now let's start with the y direction. It looks like we have another surface force, so I'm going to use the same color as the friction force. Point it up. The positive y direction. And it looks like the other part of whatever force that is going to be pointed upwards, which this is going to be, and I'll make it large. That is our upward force, and that is positive 77 newtons sine of 30 degrees. So remember, we got to add those two vectors together, which is going to be positive 38.5 newtons. So what that means is that has to be the 77 Newton force, and this has to be 30 degrees, because this angle 30 degrees has to touch the cosine. So this is our force diagram. Okay, so constructed our force diagram. Now let's move on. It looks like we have to calculate the acceleration in the x direction. We have to figure out the direction of the velocity vector as positive, negative, or 0, and figure out if it's speeding up, slowing down, or constant velocity. Okay, well, let's go ahead and solve for the acceleration in the x direction, just like I taught you. So we're going to take this, go over here, and I'm going to write it out. So we have our negative 0.2 times normal force plus, and I'm just going to go ahead and write the 66.68 newtons. That's going to be equal to 29.65 kilograms times the acceleration in the x direction, which looks like it's positive, but we'll figure it out. All right, to find the acceleration in the x direction, that looks like we have to divide both sides by 29.65 kilograms. But we can't do that right now because we have a normal force in our equation. So we have to figure out what that normal force is. Okay. And when we do that, we'll be able to solve for it. So let's use this part right here. This is going to be our normal force that we're solving for. And since we've gone ahead and figured out this is 38.5 newtons and this is 296.5, let's go ahead and subtract those two things. So the weight is 296.5, so plus 38.5 equals, that's negative 258. All right. So that's going to be equal to minus 258 newtons. And that's going to be equal to 0. So what that means is our normal force is going to be equal to 258 newtons. Let's go ahead and plug that into right there. All right, so negative 0.2 times 258 newtons, these numbers are weird, plus 66.68 newtons divided by 29.65 kilograms. Okay, so that means our acceleration is going to be equal to, let's see what we got here, 258 times 0.2 equals, and we're going to make that number negative. We're going to add 66.68, 15.08, and we're going to divide that by 29.65. That's going to be basically 0.51. And that's going to be, let's double check that. Let's just make sure it's right. 258 negative times 0.2. Okay. Plus 66.68 divided by 29.65. Yep. Cool. So that's going to be a positive number. And it looks like it's going to be a positive 0.51 meters per second squared. There we go. So let's start filling in stuff that we know. Negative 0.5, positive 0.51, 0.51. To figure out the direction of the velocity vector, friction is pointing to the left, so velocity is pointing to the right. Since the velocity and acceleration are both positive, this will be speeding up. Okay. So that's what you're supposed to do on these tutorials. The last of the types of tutorials from this assignment, we're going to be doing this. And again, we're just exercising our problem-solving ability. So now these assignments are the hypothetical deductive reasoning, where you're given the information and you're supposed to create the force diagram, create the equations, and then solve for something. In this case, solve for the acceleration in the x direction. So right here it says a person is pulling with 14 newtons of force. So this must be pulling a rope with 14 newtons of force on a lightweight cord attached to a 4 kilogram box. So the cord makes a 30-degree angle above the horizontal. There is friction present. Kinetic friction, that means it's going to be moving, and this probably should have a K here, and 0.1. And we're supposed to figure out the acceleration of the box. Okay. And it looks like it's not moving or accelerating in the y direction. All right. So let's go ahead and figure this out. And it's basically telling us it is moving in the x direction, so that's telling us which way the friction is. So let's start off with the mass. So the mass is 4 kilograms, so I'm going to write that in the center like I always do. And that means the mass times gravity, and I'm just going to use gravity as 10 meters per second squared. So that's going to be negative 40 newtons of weight. Now it says from the picture the person is pulling it with 14 newtons of force. So what's physically touching the box is this rope and the surface. So the rope is pulling with 14 newtons of force at an angle of 30 degrees. Okay, well, while we're here, let's go ahead and make our triangle and break that diagonal in up and down and left and right. So this hypotenuse is pulling up and to the right, so the horizontal portion is probably to the right, and the upward portion is positive, y. Okay, so this will be positive 14 cosine of 30 degrees, and this will be positive 14 sine of 30 degrees. All right, now that we've got that out of the way, let's talk about the surface. The surface will be holding up the box. So it's going to be in the positive f sub n, positive y direction. And there is a coefficient of kinetic friction, which means if it's moving to the right, it's got to be it's got to have its friction to the left. So it's negative 0.1 times the normal force. Okay, now we have everything we need to build the equation. Okay, let's start with the x direction. So we have this friction force and we have this pulling force. Well, the horizontal component of the pulling force. So here's the friction force. That pulling force is going to be positive 14 cosine of 30. And while I'm here, I'm just going to figure out what that is. So 30 degrees is 0.866 times 14, 12.12. So we know this is positive 12.12 newtons. All right. That is going to be equal to, since that's the only two forces, our 4 kilogram mass times an acceleration that we don't know the direction of that acceleration. It's probably going to be to the right, but I don't know. Let's do the y direction next. It looks like we have a normal force pointing up, and it looks like we have a 14 sine of 30 degrees. That's also up, which, by the way, that's just positive 7 newtons. 30 degrees is 0.5. And then we have the weight of the object, which is 40 newtons down. And that's going to be equal to 4 kilograms times the acceleration in the y direction, but that is 0. So this whole thing is equal to 0 on this side. All right. Let's start with the y direction this time. Since I've noticed the last couple problems that we've done, we've solved for, well, actually, I'm going to keep doing it the way I normally do. I'm sorry. If you don't know what to do, I should model what to do when you don't know what to do, is to follow the procedure. So let's go ahead and do this. So if you don't know what to do, start solving for the variable you're being asked to solve for. Plus 12.12 newtons, and that's going to be equal to 4 kilograms times the acceleration. And by solving for what you're supposed to solve for, that'll tell you what variables you need to figure out. And so we're going to divide both sides by 4 kilograms, give us the acceleration in the x direction, and this is going to be negative 0.1 times the normal force, and that's going to be plus 12.12 newtons. So just like always, we need to find the acceleration. We don't know the normal force. Let's go ahead and figure it out right here. So that normal force right here is going to be equal to 7 minus 40. So that's going to be, what is that? 7 minus 40. I'll use a different color here. That'll be 30. Actually, this will be minus 33 newtons equals 0. And so that normal force is going to be 33 newtons. So that is what we're going to put in for right here. All right, let's do it. So negative 0.1 times 33 newtons plus 12.12 newtons divided by 4 kilograms. That's going to be equal to the acceleration. So 33, so that's going to be negative 3.3. So 12, I got to probably put stuff in the calculator first. 12.12 minus 3.3 equals, and we're going to divide that by 4 kilograms. 2.025, and that's a positive number. So this is going to be a positive, and I already forgot it. Let's try that again. 12.12 minus 3.3 divided by 4. 2.21. Okay. 2.21 meters per second squared. Okay. Now we know what that is. So, yeah, so that is what we're being asked to solve for. So that's going to be a positive 2.21. Okay. I wanted to do one other problem just to kind of help you out, because one of your tutorial problems does have a block that is suspended by 2 ropes, but at 2 different angles. So I wanted to demonstrate how to do it just really quickly, even if the 2 angles are the same. Okay, so here we go. We have a block that is being suspended by two ropes, T1 and T2, and they're both make an angle at 60 degrees to the surface. Now this is a 2 kilogram block. I'm going to write 2 kilograms right there. And so we are asked to figure out what the tension is, the overall tension in T1 and T2 is. Now they're saying that the object is not moving or accelerating in any direction. All right, let's start off with the weight of the object. Again, I'm just going to calculate this as negative mg, and I'm going to call gravity 10 meters per second squared down. So this is going to be a negative 20 newtons of weight. So that's the weight of the object. Now I'm going to do 2 different colors. I'm going to call this T2, okay, and it makes an angle with the ceiling that is 60 degrees, and over here I'm going to make another blue and try to get this right. Try it again to get this right. Yep, nope. And that is too long. Try one last time. Okay, that looks sufficient. Here we go. So that is T1, and that makes an angle of 60 degrees with the ceiling as well. Okay, so now that we've got that started, the first thing we have to do is break up T1 and T2 in their X and Y directions. And since there's two of these, we're going to have to do this twice. So this is going to be T1. So we're making our triangle around our diagrams here. And I'm going to try to encapsulate this guy here. So here is the other part. So that hypotenuse is pulling up and to the left. Now that 60-degree angle right here, that is touching the horizontal part. So that is going to be hypotenuse cosine of 60 degrees, and that is pointing to the left. This part right here, I'm going to give myself a little space here, because I might need it, is pointing up, and that is going to be positive T1 sine of 60 degrees. I need a little bit more room. So positive T1 sine of 60 degrees. Let's try that again, make it look better. And move it over a little bit, so this is going to be positive T1 sine of 60 degrees. That's better. Okay, for T2, that is pulling it, so here's the triangle that we're working with, making a triangle around our 60-degree angle, and so that hypotenuse is pulling up and to the right. The right vector, the horizontal vector, is touching the 60 degrees, so that is going to be T2 cosine of 60 degrees, and that is positive. And this up vector, I'm going to probably need a little bit of room here and here. So we're going to call this positive T2 sine of 60 degrees. Okay, that looks good. Now what we have to do is we have to put all of that into our force diagram. So starting with the horizontal, we have negative T1 cosine of 60 degrees. And that's going to be equal, so we're going to add to that T2 cosine of 60 degrees. And that's going to be equal to the mass of, what is that, 2 kilograms times the acceleration in the x direction, which is 0 meters per second squared. So that's just 0. So what we're going to find out is this. So I'm going to copy this down again, and I'm just going to do this right here before we do anything. Goes T2 plus T2 cosine of 60 degrees, and that is going to be equal to 0. So we're going to add that T1 onto the other side. So we got T2 cosine 60 degrees, and that's going to be equal to T1 cosine 60 degrees, and those cosine of 60 degrees are going to cancel out, and we're going to find something weird where we just have an answer that says, oh, T2 is equal to T1. Hey, that's okay. It will not be the case in your problem since those two angles are different. but in this case it is. And this is a lot like one of your homework problems. Okay, now in the y direction, it's going to be a little bit more intense. So we're going to start here with this guy. That's going to be, actually let's start with the weight force. So that's going to be negative 20 newtons plus T1 sine of 60 degrees and plus T2 sine of 60 degrees. And that is going to be equal to 2 kilograms times 0 meters per second squared, which is just going to be equal to 0. So we're going to have negative 20 newtons plus T1 sine of 60 degrees. And that's going to be plus T2 sine of 60 degrees. And that is going to be equal to 0. I'm going to bring the 20 newtons onto the other side. So T1 sine of 60 degrees plus T2 sine of 60 degrees. That is going to be equal to our positive 20 newtons. Now, we just found this out right here a second ago, that T2 and T1 are equal to each other. So we have to pick which one do we want to sub that in. Since they're the same thing, I'm going to call T1 to be equal to T2. So I'm going to take this guy, I'm going to bring it over here, and I'm going to sub in T2 for that. Okay? So now we know T2, then we have our blue sine of 60 degrees plus T2 sine of 60 degrees equals 20. And so there's just two of them, so that I'm just going to put a 2 in front. I'm going to add those two together. So this is 2 T2, and since there's blue and that, I'm just going to call it sine of 60 degrees. That is going to be equal to 20. Now to solve for T2, we're going to divide both sides by 2 sine of 60 degrees. And when we do that, we're going to divide the 20 newton sine of 60 degrees. So let's figure out what T2 is, because then we will know what T1 is. So T2, that is going to be equal to, here we go. Let's go 60 trigonometry sine 0.866 times 2 equals, and then we're going to flip it, and then we're going to multiply it by 20 on top. 11.55. So T2 is equal to 11.55 newtons. And since T2 is equal to T1, they're both equal to 11.55. Okay. Yours has a little bit more trigonometry, but nothing that would be too difficult for you to handle. I do want to go over, I was about to finish the video, but I do want to go over one last problem, okay? And this at first seems quite easy, but they can be, at least with algebra, there are some nuances, and this is going to illustrate it. And this is what to do when you have two unknowns and you have to solve for something, okay? So here we are, we have our given equations here. We have a 5 kilogram object, and we're given, we're supposed to create a force diagram and label it, and then calculate for F sub h, which is this guy right here. So I'm going to put a little hat on him. And we're given that the mass is 5 kilograms. So let's start with our force diagram. And let's start with the y direction. You have the weight of the object, which is 50 newtons down. So that's negative 50 newtons. And that's going to be equal to negative mg. And it looks like we have in the y direction, it looks like in the y direction we have a t cosine of 30. So I'm actually going to start off by drawing that. T cosine of 30. So I'm going to draw that first. So that looks like there's a rope pointing up, and that's going to be positive t cosine of 30 degrees. Now in the x direction we have a negative t sine of 30 degrees. So I'm going to put this on the other side, positive t cosine of 30 degrees. And then in the x direction we have a negative t cosine of 30 degrees. We're going to add to that sine of 30 degrees. And so we could see that t is going to be here. And so this is t. So this is the tension t. And if this is 30 degrees here, since I started drawing my y direction first, this has got to be our 30 degrees angle there. And I'll use black to show that. And then we have an F sub h force, which looks like it's pointing only in the x direction. So positive F sub h. Okay, so basically it looks like a rope is pulling this up and to the left. There's a hand force pushing it to the right. So if I was going to redraw this, you have the rope force up and to the left. You have a hand force pushing it to the right. And 30 degrees, and then you have your mg vector down. That's what it looks like. All right. But the reason why I want to come here and do this is because of the equations, right? The force diagram, by now you're probably pretty good with this. So look, if you look at this, we have a F sub h force here, and we have a t sine of 30 degrees. We also have a t sine of 30 degrees here. So you have two unknowns, one equation. You really do want to approach this kind of like you've done other problems in the past. Since we need to solve for S sub h and we don't know t, we need to eliminate this guy and solve t in terms of numbers. That way, when we have t in terms of numbers, we plug that t into here, and then we could solve for F sub h, and it'll be a numerical answer. So since our F sub h is here, and we also have the unknown here, we have to use the other equation to figure out what t is. Okay? So that way, when we have a numerical answer for this, we just plug it into here, and then we're done. So let's solve for it. So we have t cosine of 30 degrees minus 50 newtons, and that is going to be equal to 0. Okay, so t cosine of 30 degrees is going to be equal to 50 newtons. And then so divide both sides by cosine. And we have this. cosine of 30 degrees. Now, don't make things difficult and plug this equation into here, and then, because it starts to look really weird, just solve this for a number. Try to keep things simple. So this is 50. Well, first of all, let's solve for this. Calculator is weird. You have to solve for the 30 degrees first, and so that's when it's on the top. When it's on the bottom, it'll look like that. We're going to multiply that by 57.74. 57.74. So T is going to be equal to 57.74 newtons. Okay. All right. Now we're going to plug this guy in right to here. Okay. So starting off, F sub H, I'm going to rewrite this stuff right here. So negative T sine of 30 degrees, which is equal to a half. And that's going to be equal to 0. So we're going to plug 57.74 right there. .74 times 0. That should be newtons. Newtons times 0.5, and that's going to be equal to 0. So 57.74 divided by 2, 28.87. Newtons equals 0. And then we're going to add that to both sides, so that F sub H is going to be equal to 28.87 newtons. Okay? So not too difficult, but just kind of helps you out with some of your future problems that you're going to have to do. So just remember, try to keep things simple when you're doing your tutorials, and try to get a numerical answer when you're in a situation where you have two equations and two unknowns. The one equation that has your what you're solving for, if that's this one right here, this t needs to be eliminated. So look to the other equation to get a numerical form of t as a number, which was 57.74, and then plug that number in right here. And that'll quicken it. Okay? Okay. I hope you enjoyed this, and I hope it was helpful. This was 4.3 2D force diagrams. Okay? Have a good day.